Okay, let's look at the concept real quick before we look at those problems. So you're kind of asking, I think, kind of for a general overview of transformation. So right here, they're using function notation, but we'll look at it with our five basic functions in a second. But right here, so if you have your function or whatever, your x squared or your square root of x, if you're adding and subtracting to it, that causes you to shift up or down. Now, the horizontal shifting, you notice the difference is it's happening directly with x. And so if you add, you actually shift to the left, and if you subtract, you shift to the right. So that's going to be our vertical and horizontal shifts. Okay, if you're going to reflect across the x-axis, that's where you throw the negative right in front of your function. So once again, could be, in this case, it's x squared. So see, this is negative x squared down here. If you're going to go across the y-axis, the negative is actually there with the x. So this would be the square root of negative x. That would be the one that is reflecting across the y-axis. And then let's see. Then we have our stretching, and that's where when you multiply the function by value, if you multiply by greater than 1, it's going to stretch it vertically. And then if it's somewhere between 0 and 1, it's going to shrink it somewhat. And then the horizontal shrinking and stretching, that's a little opposite of what you'd kind of think. If you multiply it by greater than 1 directly to the x value, it actually causes the graph to shrink horizontally. And if it's somewhere between 0 and 1, it actually makes it a little bit wider. And that's a little counterintuitive. All right, let's see. So here are one. I'm going to go through the basic functions we're looking at here. So we have x squared. So you can see that -2 will cause it to go down 2. That -1 that's directly there before it's squared causes it to go right 1. And then here, there's two of them. So you always want to do your horizontal first and your vertical last. So horizontal, we'd go right 2, and then we'd multiply y by -1. And what that does is cause you to reflect across the x-axis. Let's look at a couple more of these. The transformations don't really change. We're just going to use different shaped functions. So this one, we're going to go right 1 and then up 2. This one's right 1. And then all the y values are multiplied by 1/2. So it causes a shrinking vertically, but I kind of, instead of saying, shrink by 1/2, I just say multiply y by 1/2 because that's how you apply the description. So that's what I like to do. This last example, so this +1 causes you to go left 1, and then you don't want to go up 1 next. You have to actually go ahead and take care of this -2 that's getting multiplied by the function. And that's really two transformations. It's causing a reflection across the x-axis. That's why it's opening down. And then also the 2 is going to cause it to stretch vertically a little bit. And so what you'll notice is that it's a little bit tighter right there, that parabola. This is a little bit wider on the other ones you can see. So what you want to remember is vertical transformations are always last, horizontal are always first, and then anything in the middle, it doesn't really matter the order that you do that in. But okay, so let's look at a couple of our other basic functions. So here's our square root function. And so, I mean, it works the same way. So see that +2 is not part of the operation. So that's going to cause you to go up 2. Now the +2 is inside the radical sign. So that's a horizontal transformation. And then so on, you'll have your reflections and stuff. And basically, these are going to be pretty identical to the other ones I did earlier where I'm just mixing in transformations where there's more than one. Then let's see, we have our absolute value function. And so once again, the way you do it is no different. So up 4, left 4, left 3, down 2. And so this shape, it's a V shape. And what I typically do, and I guess I should have mentioned this earlier, is I just take a couple key points of the original function and I move those around. So those are the original points, and then I apply whatever I write down right here as my transformation. Just follow those directions there. Then our last two, we have our cubic function, which is kind of like a parabola opening up and opening down on each half right here. And so once again, the transformations work the same way. So that -3 down 3, then the -3 is part of what's being cubed. So that's actually horizontal transformation. Then I have a couple reflections and stuff like that. And the last one is the cube root. Kind of like the square root, but the cube root, which you can actually cube root negative values. So it does go left and right forever. Kind of like the one on the other side, except it's kind of laying down. So kind of like a square root opening up here to the right and then opening down here to the left is kind of the general shape of it. And so I take those 3 key points and then I'll move them around. So the first one, I moved them up 2, so they all moved up 2. Moved all left 2. Then this one was a little bit trickier because I'm going to move right 2, and then I multiplied them all by a half. And so that kind of caused them to kind of condense and made it a little bit harder to draw, but there we go. Okay, so hopefully that kind of helps. I'm going to go ahead and look at the ones that you did send so we can take a look at those. So here's our absolute value function. So if we go back to here, so what we're doing, see if it comes up. There it is. We're taking this. So we're going to take those key points and we're going to apply the transformation. So if I was looking at this, let's see, I'm going to take those 3 key points right there. And so that's going to cause me to go left 3, and then I'm going to reflect across the x-axis, or you could say, I like to say multiply y by -1. It's personal preference. If you want to describe it as a reflection, that's fine, because it is. So let's see, you do have your horizontal shift, looks good. Reflection across the x-axis, that looks good. And so the way this works is I'm going to move all these points to the left. Let's see, 1, 2, 3. So that ends up here. 1, 2, 3 ends up here, ends up here. Then it has to reflect or basically multiply your y values by -1. So that causes those points to reflect across. That 1 point right there is on the line of reflection, so it doesn't really change that. And so that looks like that lines up with B right there. Right, and then let's see. Then we also got this one here. This one can be a little tricky, especially when you're using your graphing tools. Maybe I'll pull that up and we'll look at that a little closer in just a second. But so there's your basic cube root shape, and then that +7 is going to cause you to go to the right 7, and that looks like what you did. Everything looks good on this one, actually. So you must not have had too much trouble with the tools there. Let me see if I can pull that up. Okay, so it looks like you already got it right. Let's see. Okay. Yeah, you got it correct. Let me see if I do a similar question real quick. So, but like I said, I guess you've got it all figured out. So you just pick that. It's automatically just going to show up there. And then you do your transformation. So this one's going to go left 7. So there we go. Save. Check answer. There we go. So apparently you didn't have too much trouble on that one. And hopefully this has clarified stuff. And if not, don't feel bad. Go ahead and send me another email. What we could probably do is maybe set up a WebEx and we could meet up on there for a designated time to kind of discuss this more if you'd like to. And like I said, don't hesitate to do that if you'd like to. Hope this helps.